Hello, this video is for Stat 310, handout number 9, Part A, and will include pages 1 through 11. All right, let's go ahead and get started. So what handout 9 includes is a comparison of means across two treatments, which is known as two-way ANOVA. And in Part A here, we are going to be considering just the overall test. So the situation here is that we have a school psychologist who's interested in determining whether or not Ritalin and a therapy program will have an effect on out-of-seat behaviors in a school setting. So here we have two treatments: the Ritalin dosage level, which is going to be at low, medium, or high. And then we have two levels for a therapy program here: behavioral therapy or cognitive therapy. There's going to be 3 levels for Ritalin dosage and 2 levels for therapy program. That gives us 6 combinations. Within each of these cells, we will have 5 observations. So in this study, we have 5 replicates. All right, let's go ahead and consider our statistical model. So this is what the model is going to look like. We're going to have an overall effect, again denoted by mu. Alpha I, okay, we're going to use alpha to denote the effect of the Ritalin dosage levels. So I is going to go from 1 to 3 because we have 3 levels for that. Theta here is J, has the index J on it. J is just going to go from 1 to 2 because it has 2 therapy levels: behavioral and cognitive. We have a new term here. This gamma ij here is called the interaction term. And what that's going to allow us to do is consider the effect of Ritalin and therapy in combination of one another. That's called an interaction effect. And then finally, the last term here is just our errors. Okay, so let's look at the different effects here with just a table. So let's break out what these different effects really are, just looking at our data. So before we get into all our p-value discussions, let's just try to understand what those effects are about. So here, the overall effect is going to be the average of all 30 observations here. I do not care what Ritalin dosage level they're in, and I do not care about the therapy program that they're in when I'm trying to measure the overall effect. Next, let's consider the alpha term, which is going to be the effect due to the Ritalin dosage. So if I calculate the average on the low level, the average on the medium, and the average on the high dosage levels, so doing that across these 10 observations here, the average there is going to be 53.5. Now the effect of the low Ritalin dosage level is going to be negative 1.3. So I got to get from my overall effect down to this, what we call main effect for low here. So I need to get from 54.8 down to 53.5. So I need a reduction of 1.3. So the alpha 1 term, the estimated alpha 1 term is going to be negative 1.3. Here for alpha 2, which denotes the effect of the Ritalin dosage level at medium, it is pretty close to the overall effect. So alpha 2 hat here is just 0.1. I just need to increase a little bit. I need to go from 54.8 up to 54.9. And then likewise over here for the high, I need to increase about 1.2. So the negative 1.3 is what we call the effect due to the low Ritalin dosage level from the overall effect. Okay, it's always from that overall effect. All right, so that's the alphas. What about the thetas here? Well, that's the effect of the therapy program. So here what I need to do is average this direction. So that's what we would call the main effect due to behavioral. And then the main effect due to cognitive level would be the averaging those there. So let's go ahead and look at the main effect for therapy program. So again, I need to average across all the dosage levels here. I get a value of 54.4. Now I started again from the 54.8 here. Okay, so I need to go from 54.4 up to 54.8, and that's going to be a negative 0.4 there. The cognitive average is 55.2, so that's going to be a positive 0.4. We might notice that these effects, again, are going to sum to 0. We still have that sum to 0 constraint that we talked about in Handout 8. Likewise here, these effects actually will sum to 0. So once I know two of them, I know what the third value is. Okay, how about the interaction effect now? So the interaction effect is going to simply compute the average within each cell. Okay, so it's going to look at that average within that cell across these 5 replicates. And that effect there, or that average, is 55. Now this is what's called an additive model. So what we do, or what we mean by that, is I start with the overall average, 54.8. I need to subtract a little bit because I was in the low Ritalin dosage level. So again, what is the effect of being in the low Ritalin dosage level? Negative 1.3. So I'm going to start with 54.8, and I'm going to subtract the 1.3. Now I'm also in the therapy program behavioral here. So what's the effect due to that? That was a negative 0.4 up here. So 54.8 minus 1.3 minus 0.4. Take those quantities, and I'm going to be under 55 because I'm subtracting here. How much are you going to be off, or how much are you going to be under? 1.9. So this 1.9 right here, again, is what I need to get back to this 55 here, to get the average for that cell, after I've considered the other additive effects in my model. So this is the interaction effect here for low dosage level and behavioral program. It's going to be adding 1.9 there. Likewise, for the cognitive, I'm going to do that same additive process. Start with the overall. I got a negative 1.3 because I'm in the low Ritalin dosage. I need to add 0.4 now because I'm in the cognitive therapy program. So doing all of that. Okay. And I need to get clear down to 52 here. All right. So I need to subtract 1.9 here in order to get there from those calculations. I'm going to do the same thing there for the medium and also for the high. Okay. I'm going to have to double check that math there. That might be the effect here. Let me just check that real quick. I might have made a typo there. And if I did make a typo, I'll get it fixed and just post the corrected version there. So 54.8 minus the 1.3, add the 0.4. Oh, that's correct, 53.9, so I need to drop down negative 1.9 there. So those numbers were correct. Okay, these are the interaction terms then. This 1.9, negative 0.3, negative 1.6, negative 0.9, all the way across there. And again, those will all sum to 0 as well. So let's just look at a visual display. Okay, so what we've done here is computed these averages kind of different ways. But let's just look at those 6 averages on a graph here. So this is what's called an interaction plot. We'll talk more about this as we go forward here. But I have the dosage levels across the bottom, low, medium, high. I have the cognitive in red and the behavioral in blue here. You can certainly see the large drop-off here in the average, okay, for low dosage. So when the dosage level is low, that cognitive program really tanks off here or decreases considerably. And we actually want to be low here. So the behaviors, or the response here, is the number of out-of-seat behaviors. So children that are given low dosages of Ritalin and use cognitive behavioral therapy are going to have the lowest number of these behaviors. If you're looking at just medium and high, it looks like we should be doing behavioral therapy. But that's not the case here for low. So this model is, we're going to say that this data or this model is going to have an interaction term. And we'll talk more about that here in a few minutes. All right, so one thing that I want to show you is just how to set your model up. So I'm going to go over into Jump and do that. A lot of the output you'll find here. So I screenshotted all those and we'll go through that. So to do a two-way ANOVA here, I need to go Analyze, Fit Model. My behaviors is my response. And then I need to put dosage level in my model effects. I also need to put therapy program in my model effects. And then I need the interaction term, or the cross term. And to do that, I need to select dosage, hold down the control button, select therapy, and then say cross here. And that cross term will get put in there for you. Okay, so I need the main effect for dosage, the main effect for therapy, and then I need this interaction term in there. And then I can just say OK here. So just select Run up here. Excuse me, Run, not OK. And my output is going to look much like it did before. I'm going to get lots and lots of output here. I have my analysis of variance. I'm going to have to get my expanded estimates again like I've done. Up here in the corner, we're going to want to be selecting LS mean plots, Tukey's HSD, all of that type of stuff. All right, let's go back to the handout then. Okay, the overall test. The overall test is done by looking at the p-value here underneath analysis of variance. What the overall test is really doing is just looking at whether or not there's any effect due to these treatments. Those treatments being dosage level or therapy program, or some combination of those. My p-value here is less than 0.05, so I can make a conclusion that there is some effect. If you run analysis of variance, and you find out that this p-value right here is not less than 0.05, then we're done. Because neither one of these treatments are influencing my response. So the only test you need to run is the overall test. Now here in this situation, this is less than 0.05, so I want to do a little bit more investigation. Like, is this effect due to the Ritalin, or is this effect due to the program therapy, or is the effect due to the combination of those? So let's look at the main effect for Ritalin. Now I'm considering the output underneath the effect tests here. And I'm looking at dosage. So what hypothesis is being tested here is whether or not there's any effect due to the dosage. So if there is indeed no effect due to the dosage, then all of my alpha terms are going to be 0. Alpha 1, alpha 2, and alpha 3 will all be 0 if there is no effect due to dosage. So that's how we usually write that out with the parameters from the model. In words, we are just saying there is no effect due to dosage. So if they're all 0 again, there's no effect. And if at least one differs from 0, then there must be some effect. This p-value right here is less than 0.05. Therefore, we are 95% certain that there is some effect due to Ritalin. Let's quickly look at the expanded estimates. Here I have dosage level low. I have dosage medium and dosage high. So this is the information underneath the expanded estimates. Let's go ahead and zoom in on that. So the information underneath the expanded estimates. And again, I have low, medium, and high here. we have 3 p-values over here on the right that we want to look at. And I've just labeled them A, B, and C. Now what A is going to be testing is whether or not the average for dosage level low, so looking at low here, that's what A is for, is that average effect different than the overall effect? So this here is, well, alpha 1 hat is negative 1.3. What this test is doing is testing whether or not alpha 1 is statistically different from 0. If the p-value here, so I'm talking about p-value A, if that p-value is less than 0.05, then it's statistically different than 0. How about p-value B? As we can see from the medium level is almost right on top of the average effect here. So there really is no effect to dosage level medium. How far away is this average from the grand average? Not very far at all. So I don't need any adjustment for dosage level medium here. I will need an adjustment for dosage level high. Again, that p-value right there, which is for alpha 3, testing whether or not alpha 3 is equal to 0 or something different than 0, is represented right here by that distance. That seems like it's quite a bit of distance, so it looks like I need an effect for dosage level high. So that's what those individual tests are underneath the expanded estimates. Okay, let's go ahead and move on to the main effect for therapy program. So the therapy program, again, underneath the effect tests, I have a p-value here of 0.2361. Formally, what we are testing is theta 1 equal theta 2 equal to 0. That would be no effect, against the alternative that I have something going on due to the program therapy. The p-value here is 0.2361. So it does not, that is not less than 0.05. So it appears that we do not have an effect due to program therapy. The individual tests are here. When we're doing the averaging now, we don't average within the low and the medium and the high, but I need to average across the cognitive levels. So if I take the average of the red dots here, I'm going to end up with something about there, 55 or a little bit over 55. If I take the average of the blue dots, I'm going to end up with something a little bit under that 55 or 54.8. It's going to be a little bit under that grand average there. Okay, so these are going to be what? Theta 1 hat and its associated test, and theta 2 hat and its associated test. Now again, these things need to sum to 0, so this is kind of repetitive information here. You can see that the p-values are exactly the same because they are summing to 0 there. Now let's just go back and think about what we just said. There appears to be an effect due to Ritalin, but not an effect due to the therapy program. So if I look at my interaction plot here, we can see that the low levels of Ritalin, okay, their average is somewhat smaller. Compared to the high levels of Ritalin, that average is up here somewhere. However, I think it's incorrect to say that the program does not have an impact. It doesn't have an overall impact, but when I get down to this low dosage level, it again drops off significantly. I would definitely want to use this setting if I'm trying to keep kids in their seats. So the program does have an effect. It's just that the effect depends on the dosage level. So again, we have the term for that, and that's called the interaction between those two. So let's consider the interaction test now. Or maybe before I go on, let's look at the main effect for program therapy. That conclusion that we made there, I'm going to go ahead and cross that out because that's not really true. The program does have an effect. It just depends on the dosage level. I really shouldn't be doing this test, and I'll talk more about that at the end. So let's consider the interaction. The interaction is the one that has the star between them. So you can see I have dosage and therapy here. I'm underneath the effect tests. The p-value there is less than 0.05. So what's being tested here is, does the effective program depend on dosage level? That would be my alternative hypothesis. The effective program depends on the dosage level. The null hypothesis is always there's no effect, or does not depend on dosage level. The p-value here is quite small. So we are 95% certain that the effect of program therapy depends on the Ritalin levels. There's that combination going on there. Now visually, what this test is really doing is just looking at the gap here at low level. Let me zoom in on that. The gap here at the low level, is that gap different or differs? Does that gap differ as I go from from low up to medium and up to high? And that gap does differ. Over here on the right-hand side, cognitive is higher. In the middle here, cognitive is higher, but not nearly as much. And then over here on the left side, it actually flip-flops and behavioral is higher. So the pattern that I'm seeing here is different than the pattern that I'm seeing here. Sorry about that. And is different than the pattern that I'm seeing here. If that's the case, then I have interaction. And this p-value over here is going to be small. So what would a plot of no interaction look like? Well, the gaps there would be the same, irregardless of what dosage level we're at. So in this display right here, cognitive is higher. And it's higher at high, it's higher at medium, and it's also higher at low. So if you draw your graph of the 6 averages and it looks like this, then you're going to have no interaction in that model. Sometimes that's just referred to as the parallel lines model or the parallel lines situation. So the top one has interaction. That's what we had. The bottom graph would be a situation of no interaction. The expanded estimates are here. Okay, we got so many tests going on here. We can look at all of these. The tests are referred to over here on the visual, on the graphic. I think for the sake of time here, I'm just going to skip over those. We definitely want to be considering the tests underneath the effects here, the effect tests. These under the expanded estimates are usually secondary in interest and only are necessary if I really want to know whether or not I got significant effects individually here. All right, so just final thoughts on the concept of interaction. When considering the effect of 2 factors on the response variable, we cannot do so individually or marginally. That's a very dangerous thing to do. It's an incorrect thing to do if you have interaction present in your model. The first thing that I usually do is create a graph like this for my data that I'm investigating. And that's going to give me an indication of whether or not interaction is going to be a problem. Again, if interaction is present, I cannot talk about the program level without considering the dosage level. I can't do those individually. I got to do those in combination or in tandem. Here's some more information on page 10. These bullets here, if the line segments are flat, okay, if these lines are flat across here, straight across, okay, then that's going to indicate that the factor that you have on the bottom is not important. So that's almost the case here for behavioral. It doesn't really matter what dosage level we use. The effect of the behavioral therapy is pretty much the same. Okay, so if that was exactly flat, then there wouldn't really be an effect due to the behavioral program. across the dosage levels, or that effect would be the same. If the line segments are close together, okay, this indicates that the second factor does not have an effect. So that's actually the one that I drew up here. In this situation, these two lines are almost stacked on top of one another, so there's really not that much of an effect due to the program. There's definitely an effect due to the dosage because these averages are changing a lot, but the programs are pretty much giving me the same information. So if your plot looks like this, the program therapy isn't going to have much of an effect. If the plot is flat, then the dosage level isn't going to have much effect. And then the last is just if they're roughly parallel, which we've already covered. Okay, one last comment. When we're doing these tests, the order matters. So what I presented up above is I started with looking at dosage, and then I went and looked at the therapy program, and then last I looked at the dosage by therapy program. In practice, we don't do that. Because again, I should not be looking at these main effects if I have a significant interaction effect. So if I have a significant interaction, which is this bottom one, then both effects are important and they cannot be discussed individually. In this case, we want to look at the interaction plots like we've done up above, and the pairwise comparisons must be done on these treatment combinations. If there is no significant interaction, then the main effects can be interpreted individually or in isolation. So if we don't have interaction, then I can go ahead and look at the effect of dosage, kind of independent or in isolation compared to the effect of therapy program. In those cases, I can look at those p-values to determine which is significant and what is not. And I would just do my multiple comparisons with each factor individually. You'd want to be using Tukey's HSD as we talked about in the Handout 8. So if I go over here and jump, and I look at that, I'm going to want to be selecting my comparisons here over in the right corner here on dosage therapy program combination. I want to be looking at these here. You don't want to be looking at the main effects individually here. So we can hide those right away. If it turned out that I did not have interaction, then I wouldn't need those, but I could look at these and kind of in isolation or individually. I would be wanting to get my LS means here and my LS means here. Okay, that does it for this handout. Thank you much, and have a good night.